Hello everybody, welcome to this new Pix4D webinar, and today's topic is the orthomosaics. My name is Olivier Kung, and I'm very happy to have you to this webinar today. As usual, you can ask questions live in the little chat box if you're watching this webinar in live, and if you watch a recorded version on YouTube, please feel free to ask any questions to the support team, support@pix4d.com. With that said, let's start the webinar with the agenda of today. We're going to start with talking a little bit about the Pix4D mapper outputs, which type of files are generated, and how can you open them. Then we'll go a little bit into theory about auto-rectification. What's the difference between simple stitching and auto-rectification? What is the limitation? What are the benefits? We'll talk also a little bit about the impact of the illumination changes in the projects for your orthomosaics. And then we'll show two different tools to improve the orthomosaics and to reduce artifacts in them. The first one is the rayCloud, and the second one will be presented by Miguel, which is the Mosaic Editor, which allows you really to get really quite advanced in orthomosaic editing. Finally, we'll conclude with a few tips and best practices on how to obtain the best orthomosaics. All right, Pix4D mapper is outputting many files by default. Let's go directly to check the folder. In this illustration folder, you have the P4D file, which was used to create the project, along with the folder which contains three main folders. The one which is interesting for the orthomosaic is the last one, called DSM Auto. Inside of it, you will find two folders, one which is the DSM and the other is the Mosaic. Inside of this Mosaic folder, you have on the root a few files. This one is probably the one that interests you the most. This is the full orthomosaic in GeoTIFF format with transparency on the border. If you are using some older software to visualize your orthomosaic, they may not support a transparency layer on the side, where my mouse is right there and there. So you may want just to load this file, which doesn't have transparent in it, which is only a RGB image. You can also see that there are a few other files next to that. These files are text files that you can open in a text editor. The first one, the PRG, is the coordinate system in which your GeoTIFF was generated. The second one, the TFW, is the coordinate of your orthomosaic in this coordinate system that was just mentioned before. Note also that the orthomosaic in TIFF format contains inside of it these two additional files, meaning that if you take, for instance, a software such as Global Mapper, and you open it in it, the Global Mapper will automatically recognize the coordinate system and the location of your file thanks to the projection and placement which were both inside of the GeoTIFF format. In addition, you also have a folder called tiles. This folder tile is actually a subset, is a tiled version of the final mosaic that you had in the root folder. And each little part are little subsets of 5,000 by 5,000 pixels of your orthomosaic. They are used during the processing to generate the orthomosaic, and only at the end, after all of them are created, there's an additional process which will merge them together in one single file that you can find here. Once this is done, there's also an option in the software to generate Google tiles. These Google tiles are much more than Google tiles. They're actually a KML file that you can open and display in Google Earth. It is also a HTML file which overlays the Orthomosaic on top of Google Map tiles. In addition, you can see these different folders there. These are each directories which contains inside of them small tiles at different zoom level. And you can use also these generated files as a TMS server. If we look in the software, where can you find these different options? You go in the software, you click on Options, and you select the tab DSM and Orthomosaic Generation. And there you can see the relevant information. You can check the Google Maps tiles and KLM if you want this folder to be produced, but this is going to take quite some additional time. In addition, you can also check or uncheck the merge tiles, which will generate or not the main Orthomosaic out of the smaller ones. So let's now go a little bit more in details about what is really Orthomosaic. And for that, we will start with what's a mosaic and how do we put images together. So let's go with the very naive way. We have two images taken by UAV that you can see on the left, on the right of this slide. And if we try to stitch the image together in a very naive way, we would basically try to rotate them, change the scale, and maybe change a little bit the shape until they fit together. And they kind of fit together in a very simple stitching way. However, there are many, many issues by proceeding in this very simple stitching way. And the one which is the easiest to see is basically the fact that as you are flying very low, you see the facade of the buildings. Now, if you have the facade in one direction, very likely in the other image, you will have the facade in the other direction. And by trying to put them together, you will have very weird results there. In addition, if you look at the footprint of this building, of the roof and the basement, normally for this square building, they should be the same size. However, if you now try to measure in pixel the length of the basement of this building versus the top, you will see that the base is almost 50% longer. Which means that if you proceed in this naive stitching way, you cannot measure in this image. You cannot also have a proper georeferencing of this whole data set. And you will see side of buildings and side of objects everywhere. And it's going to be extremely complicated to have a project with all the images together. The main reason for all this, why does this not work that easily, is because of perspective. Perspective is a process which actually is in your camera. When you take an image, the size of the objects in the 3D world are changing with respect to the distance to the camera. So in other words, objects which are closer to the camera will have more perspective than objects which are far away. And for instance, an object which is 2 times closer to the camera might look may look 4 times bigger than what it is in reality. And this is causing all this distortion of shapes as soon as things are not exactly flat. So what can we do against that? And this is where we introduce a process which is called auto-rectification. It's basically the process that goes from a perspective camera, from a perspective image, to an image where all the dimensions are measurable and where you don't see any facade and any side of objects, only the top of them. This process is incredibly useful, and it's a bit what you see when you have satellite imagery. This is also auto images. And it's important not only for buildings, as we showed before, where you can see the different facade of buildings, but for mountains, hills, actually any slope, and any little details like roads, bridges, but even cars, person standing and everything. Everything which is slightly above the ground or slightly changing the shape of the ground, like a slope, a tiny hill, needs auto-rectification. Otherwise, you will have either very large artifacts in the stitching, and you will also have that the whole thing is not measurable, that everything will be very likely very wrong when you try to measure it. And this auto-rectification process is absolutely useful for anything which is not exactly flat. So let's see how it really works. You take a camera and you take a picture with this camera. Very likely, you will have some perspective on it, and not very likely, actually, you will have perspective on it. This is how camera works. Which means you will have not all the parts of the object will have the same size, even if they should have. Now the way to do it is, once you have taken this image, you can project it on top of a 3D model that you either computed another way or have it by by other means, but you need to project your camera, your image taken from the camera on a 3D model. Once you have done this step, you can then extract an auto-rectified imagery by computing a projection in the Z direction of this 3D model. And this is the process which is happening every time you do auto-rectification. So for that, you need many things. You need to know where are the cameras. So you need to calibrate your whole data set. You need to know what the position and what's the internal of the cameras. So that's the whole step 1 of the processing of Pix4D mapper. In addition, you also need a 3D model, which is the step 2 of processing of Pix4D mapper. And from the step 1 and the step 2, you can then compute the orthomosaic, the auto-rectified mosaic. However, in this process, there is one limitation, is that you need an extremely good 3D model. You need actually a perfect 3D model. If you don't have a perfect 3D model, then that's exactly the time where artifacts start to happen. And in this slide, we show 2 examples of such artifacts which may happen. The first one is noise in the point cloud. So when you have a house, when you have in an urban area, and the data set is quite complicated, it may very well happen that you have a little bit of noise when computing the 3D point cloud around buildings. And if there is noise in the point clouds, then when generating the DSM, there will be also noise and some spikes. And when this happens, when using this DSM to generate the orthomosaic, you will also see this type of noise on the side of buildings. Another artifact which also may happen is sometimes it's very complicated and almost impossible to generate accurate 3D model. In these particular examples, there was the vegetation was not very dense, and there was a lot of wind, which made all the trees, all the vegetation move a lot between every pictures. Due to this reason, 3D point clouds could not have been computed in this specific area, which means that the 3D was not there. And by doing the wrong projection on a 3D model, which was wrong because the 3D could not be computed, so it was estimated with a plane on the ground, then there is some artifacts happening. In that specific case, you have a stretched area, but another one which is also often visible when this happens is when there is duplication of feature. Like you would imagine a chimney on a roof. Potentially, if this chimney was not computed perfectly in 3D, you will maybe see it on one side of the roof and on the other side of the roof, where actually it should be just a small square in the middle. Another big impact on Orthomosaic is illumination changes, and especially when you have images with very, very different type of brightness and when you try to make the Orthomosaic out of them. Pix4D Mapper performs localized color and brightness balancing for you. So in this data set, at the same spot, we had an area which was really way too bright because the camera chose some settings which made the pictures look way too bright, and in another one, quite a dark one. And you can see that in the final Orthomosaic, you don't see any huge variation of this data because Pix4D Mapper was able to correct it locally. Another type of illumination change in your data set to be aware of is specularities, reflection. Basically, it's a property of the material, in that case of a field, which doesn't reflect the sun all the time in a nice uniform way. And what we see there is basically you can see the sun, which is reflecting on the field. However, this reflection is not a feature of the field. It's actually some artifact which is moving from images to images. So this was taken exactly a few seconds later, and you can see that the bright spot has moved in the picture. This is the reflection of the sun. It's not the sun. The sun hasn't moved that much, but the reflection depends on the angle of view of the UAV. So even if you change half a degree, this reflection can change a lot in direction. The good news is that Pix4D Mapper is also able to handle most of these cases thanks to the huge redundancy of the images. So the software is going to, as this bright spot is moving, and each pixel of the final Orthomosaic are usually seen by 20 images, the software will basically be able to detect that only a few of them are extremely bright and discard this information to make sure that you have a nice uniform field. However, there are some limits also to this automatic color balancing and brightness adjustments. And when you have really huge brightness changes over a very large area, Pix4D Mapper will not adjust them for a very good reason. Is if you would adjust, like we have this data set which is 3,000 images, and you can see there was a big cloud here, and just during these stripes of images, there was the cloud disappeared and there was a big amount of sun which made everything look brighter and then again look darker. If we would put the whole illumination similar on the whole data set, you will lose a lot of content in terms of contrast, because you will not, every time you change the contrast and you try to adjust automatically when there was no data at that exact brightness before, you are making the quality of the Orthomosaic locally much worse. So that's the reason why Pix4D does not adjust it for very, very large areas which have illumination changes. but does it on a local scale. All right, so now just to summarize a little bit, we explained what's an orthomosaic, what is the impact on having a good 3D model on it, and what's the impact on illumination on it. So Pix4D Mapper gives you tools to edit, improve, assess, and really enhance your orthomosaic by multiple ways. The first one I'm going to present now is by improving the 3D model. Thanks to the rayCloud, you can introduce objects, and in objects you can put them such as a way that they will also improve the DSM, and by improving the DSM, you will also improve the orthomosaic. So let's give an example. Here's the house of this is the same house that we saw in the previous examples. In this house, you can see that the point cloud is a bit noisy on the edge. However, in the rayCloud, you can introduce a surface around this roof. And if you do so, by introducing surfaces and generating the DSM again, you will see that there will be a huge improvement, especially in the borders of the DSM. So on the left, you can see a DSM that was generated automatically in this very difficult example. And on the right, you can see the DSM that was generated after adding surfaces in the rayCloud around the building, the contours of the roof. And after the DSM, the orthomosaic is generated using the data from the DSM, and that's where you can see the difference. This is an orthomosaic generated automatically, again, in that very difficult data set, where you can see these little artifacts on the side, like noise, a bit of noise artifacts, which are due to the wrong geometry computation. On the right, however, if you look at the edges of the roof, you can see that they are perfectly straight with no little noise like that. This is because the 3D model was improved, and by improving the 3D model, you improve the reprojection, and so you avoid doing any artifacts. So let's give an example of this directly in the set. So the roof of this building is right there. And you can see, let's look at the images. That in this area, the image was very noisy, was saturated, and had chromatic aberration to the quality of the lens. And that explains the reason why the 3D points are a bit more noisy exactly in this area. The way to improve the orthomosaic for that right spot is you click here on the Create New Surface Object. You then select the contour of the roof. And to be extremely precise, you can be sure to readjust the vertices that you just clicked to be exactly going on the border of the roof, thanks to the rayCloud editor. For more information on how really to use this surface tool, I would direct you to watch to the other webinar, which was entirely about the rayCloud and how to do the adjustments and how to improve the measurements done in this tool. Okay, after doing this enhancements, you will need to go in the local processing. You would need to uncheck step 1 and step 2. you can also leave them checked, but it's going to take more time to process. So I would just advise that you can directly uncheck 1 and 2, and click on Start Processing DSM and Orthomosaic Generation. If you look at the resulting orthomosaic, you will see that the roof edges will be perfectly straight. However, as an additional tip for this specific example, you can see also that there was a few points computed wrongly here, mostly because there was a small kind of tree right in front of the building. But this is confusing the algorithm. It's potentially adding noise to the orthomosaic. So the way to do it in that case would be also to define an additional surface on the ground. And this surface will make sure that any points which are in this area will be put exactly on a flat plane and removed. And this way you can generate an orthomosaic which doesn't have any tree artifacts due to the 3D model, and which will have perfect building edges. All right, so this was the way to how to improve orthomosaic using the rayCloud editor. And now I'm going to pass the microphone to my colleague Miguel, who's going to present you how to use the Mosaic Editor to improve your orthomosaics.
Okay. Hello, everyone. It's Miguel from Technical Support. So what I will explain here is we will open the Mosaic Editor, and then we will navigate through the different options. And at the same time, we will see in detail some basic corrections. Then what we will do is we will display some examples where we can see different problems that they may appear, and then how to correct it. So once we have the Mosaic Editor, the first time that you open it, it will load the Orthomosaic and the DSM. It may take some minutes, and then you will have it in the screen. As with the rayCloud, you can pan, you can zoom, and then let's go to the editing part. So one of the biggest issues that comes with the Mosaic Editor is regarding the buildings. So how can we correct them through the Mosaic Editor? We go to the Mosaic Editor, we go to the tools, and then we will create a cell around the object that we want to correct. We click, and then we are forming the vertices. With the right click, we will form, undo, click. We click. Once we form the vertices, we right click, and then we click on Insert Cell. It is important that you create the object using vertices that they are forming a planar surface themselves. Not all of them, they need to be at the same altitude, but the vertices that you create, if they form a planar surface, that will be recommended. Once we have created the cell, we can adjust it a little bit to ensure that our object is within the limits of that new cell. And then when we select the cell, we can see that by default, an ortho projection has been selected. If we click on Image, we can see the image that has been used for that cell. We can use different images that they will form the content of this cell. We have them available here. So we start with the ortho and we see the distortion. So how can we correct it? Sometimes it happens that another ortho projection is good enough and does not create artifacts. But with buildings, that will happen rarely. In general, with a building, we will need to go for a planar projection. In this case, we have seen that this planar projection has more or less exactly the same scale that we have seen with the ortho projection. If we check the limits of the edges of the roof, we see with one and the other, and we can notice that there is a very, very few difference. If we would check another projection, then we can see that not always they will maintain the scale, and that not all of them they will be perpendicular to the surface. In this case, the first one has been the most perpendicular, not always happens. So when you select another cell, if you are not satisfied with the projection that you have achieved, you can navigate and check another ones to find one that will fit more the perpendicular projection. Here, with this example, this cell is quite good because there was one image that was more or less over the object. And that shows how important can be the overlap for the editing the orthomosaic. If you are working in a project where you have a lot of objects that they could create artifacts, even if you have a good enough overlap to produce a good model with a good point cloud, still, when you go to the editing, then you can face some problems. A very good overlap will help you in the step 3 with the Mosaic Editor to select much more options, better projections for the cells that you create. So we have created this cell. Here, another thing that happens often is that with moving objects, they will disappear. They will appear in one cell, not in other, and then when you create the mosaic, it will have the ghost effect. As we will see later with one screenshot, it will appear here like blurry, and like part of the car has been projected, part not. How do you correct this? So then what we will do is we will create one cell around the objects. We can do it as well from the main bar, insert cell. We left click in the vertices to form the cell, and then with right click, insert cell. Then again, by default, it comes the ortho projection. Then let's navigate directly through the ortho projections. We don't need planner, and we can find one that in this case will not have any car. So we can go directly for this. We don't need to go to any planner. We could as well check with the planners, and potentially, as we can see in this case, the difference between the planner and the ortho, it's minimal. One trick here is that once you have this part clean, later on when we are blending the mosaic, there are some effects that they may appear, because when blending, the blending factor will take in consideration for the parts that they are between two cells, all the borders from this cell, as you can see in this hand, they will have as well one little effect using the cell, the neighbor cell. As bigger as is the neighbor cell, as more impact will have in this selected cell. In this case, this cell is quite small. The cars, they were very close to the borders of the cell, and the neighbor cells, they are quite big. So the blending factor will have a big impact, and they may create still the distortions here. How can we avoid this? Then what we do is we can create some little cells and we could do the same here, or divide this cell, a split cell. We click on the vertex, right click, a split cell. And we could do the same here. Let's create one cell here, insert cell, insert cell. Okay, so then when we are applying the blending, we will consider the neighbor cell, as this cell is not very big, and then the impact will be lower. You could say, but in the neighbor cell, there was no car. Still, even if the selected cell has no car, we may consider as well other points that they don't appear and where the cars could be. So for security, you could create this, and that will be improved. Another effect that comes, as Olivier has been describing, is when there are different lightning. How can you correct when there is different lightning? You can select the cell, and then you select the projection, the image that you want to display, and we have here these parts where we can change the illumination for one individual cell, color, and brightness. Sorry, contrast and brightness. We reset. In this example, the dataset more or less has the same light, so we will not see an effect. But when we show the examples, then we will see the impact of the brightness and contrast, and how useful can be to correct that parts. Okay, so once you complete the editing, you have to produce this model into a file, create the orthomosaic, because when we are working with the orthomosaic, a new file, when you open it, is created. It's a .p4s file that is stored in the same folder where is the project under a folder called view_mosaic_editor, which is at the same level with 1_initial, 2, and 3, the outputs from the other steps. The fact that we have it there, it does not mean that the output is created. We need to create the output. And at the same time, when we have created that P4S file, it has been created what we have displayed at the beginning. We have now done some modifications, so we have to save them. We go to Mosaic Editor and we click on Save Mosaic. Then that P4S will be modified and will have the modifications that we have done. We have one option that we don't activate by default, that is Auto Save Mosaic. If you select it, now we can see that it's selected. Every 5 minutes, the mosaic will be saving to that .mp4s. So now when you have the mosaic, what you do is go to the blending. We can go to the Mosaic Editor, we go to the tools, and then we go to blending mosaic. When we go to blending mosaic, we can see that we can modify the resolution. By default, comes the same resolution that we had previously in the quality report, as well the one that is decided in the step 3. The blending factor, later we will see with one screenshot, 0. It will have less impact than neighbor cells, and 1 will have the maximum impact. We have 0.5, and it's what is recommended. Under certain circumstances, you may modify it, but in general, it's not needed to modify. It's better to work directly with the cells. At the same time, we will display the results that we will get, the size of the mosaic, and how many tiles will be created, even if one merge mosaic file will be generated. We see the blend region, but we could as well potentially modify it. If we go to Mosaic Editor, Tools, Set Blending Region, then with the left click, we are creating the area, and then right click, Insert Geometry. Then we can see that only these points, only the area that is in this part will be generated. But as we create one square file, the points that they are outside the blending region, but that they are still within this square, they will appear, but they will be transparent. They will have no content. Only the points within the area will have content. Okay, so um, one optional thing that we will explain now is how to reset the mosaic. We have seen that this structure that came here came by default. It's a triangulation that decides which triangles are created, which cells, and the content, and how big they are. But potentially we could edit as well that. If we go to Mosaic Editor, Tools, Reset Mosaic Mesh, we can see that by default is selected triangulation. But we could change to a rectangular grid. We decide in how many different rectangles will be created in horizontal and in vertical. If we want 8 by 8, we could mark it. Then we will have a grid with 8 columns and 8 rows. We can as well use the hexagonal grid. Regarding which one is better to use, this is extremely subjective because that will depend very much on how the people prefer to work. The characteristics of the rectangular grid is that all of them, they will have the same size and they will have 4 vertices. So if you prefer to work with less vertices and then maybe you add them cells or you create a lot of cells, you may prefer to have the rectangular grid. The hexagonal grid, they will have 6 vertices. So it may be that you prefer to work a lot moving the vertices and not creating so much cells. So then you may prefer the hexagonal grid. But you may as well take the triangulation, that is the one that comes by default. And then if you have some objects, you just create a cell around that object and the rest you leave it. At the same time, when we are resetting the mesh, we can select a planar. In case that you have a lot of buildings, you may prefer to have planar. And in that case, maybe what you will need to do is mostly work adjusting the cells, but not converting so much into planar. That could be recommended if your project is full of objects where the orthomosaic projection you think that will not work. So after you have completed step 3, you have noticed that nearly every part of your project had a problem. In this case, you have to be very careful, check every part that the stitching is not affecting. Okay, so once that we have seen this, what we will see is some examples of some problems that we have noticed and how to correct them. Okay, so here we will see one example of how was the orthomosaic generated. We could see that in the top left part, there is some issues in the water, in the grass. We can see as well here a different contrast. In this one, we cannot see in detail, but later on, when we zoom in, we will see that there are some problems in the buildings and as well with roads. This is the model that we obtain at the end after applying changes in the Mosaic Editor. So we see now in more detail, zooming. This is that different artifacts that they were created along the water. This is the result that we achieve at the end. This is how was the mosaic before we started to do editing, where we can see that there is cells that they have different colors. Because when the images were taken regarding the reflection, it created like the water produced different types of brown in this lake. So when we see what we created, we directly created a big cell around the little island. We created another one big. We were working with the hexagonal grid, and then we could choose projections that they have the same color. We adjusted a little bit the color properties, but we can see here that we have more or less exactly the same. Not exactly, you can see here that there is a little difference, but we were working with less cells, so we could achieve a better result. We can see as well that in this corner, we created a bigger cell, And then we just needed one projection here to create with the object with no distortions and to don't create here an effect. Here we can see that there are some artifacts with the trees. Here we can see in more detail. This is the result that we obtained. How did we obtain it? Here we can see as well in detail. The cell was ortho, and we can see the distortion. What did we do? We created a big cell, and we were just searching for another ortho projection. You can see that here we even didn't need to select a planar. We just selected one that was enough perpendicular. We created a bigger cell perpendicular to the content that we were trying to display, and then we could clear it. Here we see some artifacts, the same type of artifacts. Here you see the result as well. Is good like before. Oops. 1 second. Yeah. Here you see that the mosaic generated a more problematic effect. Much more cells, more problems with the lightning. How did we solve it? We created big cells. We were working in the contrast and the illumination. Here in this case we had to select one planar, but the planar kept the same scale that the trees. You can see that it's very, very perpendicular. Again, with all these examples that we are showing here, and now you can see how important can be the overlap to get good projections when you edit with the Mosaic Editor. Here we see a problem with the lightning, not the object itself. And we could clear it. How was? For any reason, there was some cells that they were taking another projection with different illumination, and then we created bigger cells, and then we could easily select cells with the same light. Here is one problem that comes, for example, for roads, bridges, where it's a little bit difficult to reconstruct. We could clear it quite good. This is how it was created, and the modifications we use. Here we can see ortho is selected because this house, to show that we could select one ortho, not always you need to convert into planar for a house or a building. Sometimes an ortho can be enough. These ones we were creating planar, and then you can see that we were creating along the road. In case that your data set does not have good overlap and or that the projections they are not good enough, and you need to split in more pieces, and even you can change the size of this cell by moving the vertices closer to the limits of the road. That will help in a lot of cases. Okay, here we see the ghost effect, and as well we see the building. Here is the result that we obtained. Here is how it was, like what we have seen in the Mosaic Editor before. And we just created a big cell, we selected planar, and like this, it was automatically solved. Just as curiosity, this is how looks that bridge with Google Maps, and this is how it looks with an orthomosaic produced with our software. Okay, now we will see more different examples. Just a quick thing, the blending factor that we saw before. In this image, we can see when the blending factor was 1. And here we could see applying blending factor 0. So that's why if you apply a limit blending factor, it may help for some things, but they have a negative impact in some others. That's why it's better to try to keep it in the middle and think of different ways to solve the issue and not through the blending factor. So let's see more images. Here, one of the tricks is what happens when your building does not fit in one cell. It's a very large building. You can see that even one projection, if we could create one huge cell, still that huge cell would not cover the full building. If we could create just one cell around the building, some parts will be white and some parts they will have content. So we cannot create it with one cell. What can we do in these cases? Here we can see more detail, the different artifacts. Then what we do is we start to correct from the borders to the inside. We have created cells in the borders of the building. Then here we will see the different projections that we use. You can see that in some of them, we can see in the top right, P518, we were using that one in 2 cells, but then we had to change to the P410. We change it, and you see that we have select different um, projections along the building because one was not enough. Still, it's not just by creating cells around the building and then everything should be fine. You have to see how you create the cells and which projection you use. We will see in more detail by zooming in these different parts. Here, we can see, for example, that in this case, these 2 cells, they came from the same projection, so it's perfectly. If here it would not be the same projection in the top part, you could move the vertex to adjust to the line, and then that would help. Here as well, there is a little gap, but it's minimal. We have corrected here quite good. Here, it's very good, this example, because we can see that in the top part, it was using one projection, and on the left, it was using another projection. Why we had to create this V shape? Because the projection that was in the bottom, it went off the limits of the building. It arrived around here. And this projection, the top projection, it was above the limits in this way. So that's why we created one projection to clear one face of the building and another projection to clear another face of the building. Still here, we can see that there is a little gap, but then it's minimal. Here we can see that there is something that it may appear sometimes. How you can correct this? If you move the vertices, but then you have to be careful because then you will distort little bit. So sometimes it's even better to leave it just like this than try to correct to be so perfectionist because then the impact can be worse. Another building that is quite big, we can see the distortions. Obviously, this one could not fit in one cell, and we can see what we did here. Here we divided into a lot of different cells, and then we'll see some details. When we create them, you can see this little effect, and then now we will see why moving the vertices to the limit it will works. You can see here that then there is no effect at all. We can see here that we have created this very in the limit just in case, because maybe this projection was going much further. So we use this projection to set up the limit with the white line, and then the other one, we don't care how it was in this part. Here we can see that we have created 2 bars for this side. We can see one and the other. You can see here, you can see very well the line. We set it up here because this cell, it was much larger, but it was out of the proportions and the scale considering what we have seen in the orthomosaic projection, in the best orthomosaic, the more perpendicular. So how could we clear this if this cell was very good, but it was off limits? In the facade, we created one cell where we were just selecting the white part to set up the limits, the borders. Here, we can see one example when something goes very wrong and we have to find a workaround to solve it. We can see that in this cell was okay, but why we created the cell, the vertex in this point? Why the cell has this limit? Because there was more white here, the building was over, but we know that this is supposed to be the shape. So we then moved the vertice to create with that the shape. We have seen here that even here it was even worse the effect. It came out here much more. So we had to like cut manually. We had to select this projection because other projections they were not good enough, and this one still kept very perpendicular in most part of the content. Here we can see that there is not so perpendicular, but we could not choose better one. Here we see a little effect, but still here we can see the same. We could not clean it more. Potentially, if you could move the vertex like before, you could clear it. But when we see the final result with the orthomosaic is quite good. Here we see another example of how you can build it. Here what we will see is one example where there was very few overlap, enough to make the reconstruction, enough that there is no holes, but we had to see very bad projection. This is the best that we could achieve because for every cell there was very few projections that we could select. So then obviously the projections, they are not perpendicular, and then they are displaying the facade. You can see that here is totally distorted. In some parts we see some facades, in others we see others. Here is what we could do. Here we were even cutting to try to keep the scale at the same time here, but the result is so bad. So you can see that in some cases, maybe if the data set is too bad, it's better to live with the orthomosaic or really think about getting a new data set with much more overlap. Okay, so that's all from my side. And I will give you back Olivier, who will continue explaining you things. Thank you.
All right. Maybe just as a last tip on the mosaic, if we wanted to quickly modify most of the parts where there's building for this one, there's the possibility to use the shift. We need to go on the edit mosaic modes, and there we can select multiple cell at the same time by pressing Control, and by click on the right click, you can make them all be planar projection. So if you needed to very quickly make very quick modification, instead of being very careful for each of them, you could also just select a few of them and then go into planar projection. You can even use Control A, which will select every single cells and then switch them all to planar projection. These are a few tips to make some part of the clicking much faster. So just to summarize now what we've learned there, and what are the best practices to have to do the least amount of work as possible. The most important for getting a really good orthomosaic is a lot about image acquisition, the way you acquire image. And one of the big lessons is that if your images are really looking nicely at the ground, very likely you will get better orthomosaic than if you have images looking more oblique, more on the side. So it's really worth to take the images nicely watching on the ground to generate your orthomosaic instead of having them a bit more oblique. Another important lesson is that the 3D model is extremely important to generate the orthomosaic. As this one will correct most of the perspective and not creating artifacts. So generating, making your data sets such as the 3D content can be nicely generated, and usually this is by having sufficient overlap. This definitely help to have automatically a nice orthomosaic. Something also to remember is that, as I said in the beginning, the perspective is depending on the distance between the camera and the object. And the closer you are to the object, the effect of perspective increase not linearly but quadratically, meaning that the further you are away from objects, so the higher you fly your UAV, the less perspective you will have in your images. And if you have very little perspective, then there's little to correct. And if there's little to correct, there's little possibility to go wrong. And thus, automatically, you would have less artifacts. So if the concept is really to get very, very nice orthomosaic automatically, we would recommend to always fly as high as possible for that. Of course, with respect to how much ground sampling distance you can get. Now about the radiometry, about the look, not just about the geometry, but also about the illumination. As a best practice, it's really much better when all your images have the same amount of brightness overall, which usually means that you can fix your camera settings, which is usually the exposure, the aperture, and the ISO, and by fixing them, you can potentially have a mosaic, all images which are of equal brightness, and by default, this is always going to work much better than if you have very, very disparate amount of brightness. And however, if you have some changes that cannot be, you cannot improve using your changing the settings of your camera, or that the changes were too big, so the software was not able to automatically adjust for them, then you can always use the Mosaic Editor for localized changes. And as a last tip is one best practice again is to avoid saturated part in images. Saturated is when you have fully white areas in your images, because as also explained before, these places will have no 3D information, so you cannot compute any 3D from that. And if you cannot compute, you cannot model the terrain, and potentially you will have more artifacts in these specific areas. All right, so that was for the summary of what we've learned today. And from the automatic way, you have the mosaic generated, and then you have the two tools, the rayCloud that allows you to very nicely improve the 3D to improve the orthomosaic. And you have also the Mosaic Editor that allows you to select which image will be selected at the end to do the mosaic, and also which has the planar mode, which is another way to make it visually more pleasing, but and which is also quite efficient to perform. With that, we are reaching the end of this webinar. I'd like to remind everybody that you can always go on our website to get a free 1-week trial of Pix4D Mapper. And also that all the videos and all the webinars we've been doing are all available on our support webpage, so you can watch them later